Ballistics and zeroing. There are 3 ballistic phases. Ballistics. Definition. Everything that happens to the projectile from the time the primer is struck by the firing pin until the projectile comes to a complete stop. There are 3 ballistic phases. Internal, external, terminal. Internal. Everything that happens to the bullet from the time the primer is struck until it reaches the muzzle of the barrel. External. Everything that happens to the bullet from the time it exits the muzzle until it reaches the target. Terminal. Everything that happens to the projectile once it comes in contact with the target. Of the 3 phases, we will discuss 1, external ballistics. Gravity and air resistance have a constant and continuous effect on a bullet passing through the air. This constant effect causes the flight trajectory of the bullet to be a definitive and uniform arc. A common cylindrical bullet has no loft capabilities, as does an airplane wing. The sole purpose of the spin that is imparted upon a bullet is to keep the projectile from tumbling end over end. A bullet fired from a true horizontal barrel begins to slow down and fall towards the earth immediately upon leaving the muzzle of the weapon. Understanding external ballistics will allow us to engage targets better at varying distances by knowing where it is in relation to our line of sight, or more commonly, our point of aim. When dealing with external ballistics, there are a few misconceptions that must be cleared up and some basic facts that must be identified. The flight of a football. A common children's top. 2 basic concepts that are common to most of us will help you to visualize how a bullet is sent through the air when leaving a rifle barrel. The flight of a football. A common children's top. The flight of a football is almost identical to the flight of a bullet. Spin is put on the ball to cause it to fly on a straight axis and not tumble end over end. The line of departure or angle at which you throw the football is in direct proportion to how far you want the ball to travel. If a common children's top is spun, it will continue to try and right itself so long as it is still spinning. The harder the top is spun, the more stable it is. However, once it runs out of gas, or stops spinning, it falls over. This illustrates the principle of gyroscopic stability, which bullets use to maintain their stability. Causes the bullet to fall towards the earth. Air resistance. Bullet trajectory. A bullet flying through the air is acted upon primarily by 2 forces, which change the direction and velocity of its motion. These 2 forces are: gravity, causes the bullet to fall towards the earth. Air resistance, causes the bullet to slow down, causes the bullet to fly radically and tumble. Gravity's force acts constantly on the bullet. The effect of air resistance is dependent on the bullet's shape. For this reason, rifle projectiles typically have a very pointed tip. Bullet trajectory cones. We try and counter these forces on the bullet in 3 basic manners. 1. Increase the angle of departure, elevating the muzzle, to counter the effects of gravity and allow the bullet to reach further distances. 2. Impart spin, and 3. High velocities on the bullet to counter air resistance and allow the bullet to fly in a nose-forward manner at far distances. Parts of a trajectory line of sight. This is what the shooter sees behind the sights and can be illustrated by drawing an imaginary line from your eye through the rear and front sights up to infinity. This is how you aim. In order to align our weapon with the projectile path, or trajectory, we need to understand a couple of definitions. Line of sight. Line of bore. This is an imaginary line that is drawn from the chamber where the bullet lies through the barrel out to infinity. It is also the path the bullet would take if gravity and wind resistance weren't a factor. It would in effect be a laser. Line of bore. Trajectory or path of bullet. The path of flight that the bullet will take when it is fired from the rifle. The following is an example of what happens when a bullet leaves the bore of a rifle in which the barrel is horizontal to the ground and the line of sight is parallel to the line of bore. Path of bullet. What has to change to be able to engage this target? Path of bullet. 300 meters. 300 meters. Path of bullet. Increasing the angle of departure will allow the bullet to impact the target at the given distance. This causes us to lose sight of the target. To be able to aim at the target, the sights must be adjusted. Parallel sight and bore relationship. Lowering the front sight post. To effectively hit our target, we must modify the relationships of our three previously defined factors. The front and rear sights and their attitude in relation to the line of bore are the keys to success in this process. Reacquire proper sight alignment. And you have elevated the line of departure. Parallel sight and bore relationship. Raise the rear sight. Remember that the bullet will go where the barrel is pointed. Sight alignment and adjustable sights allow us to elevate the barrel, yet still have a proper sight picture. Reacquire proper sight alignment. And you have elevated the line of departure. The diagram below shows us how the Army is able to zero at 25 meters and still be center of mass on a 300 meters target. Line of bore. Line of sight. You will notice that when zeroing at 25 m, this causes the bullet to initially cross the line of sight at 25 m. Because the barrel is elevated at this time, the bullet continues upwards on its ballistic track. Eventually, as you can see, the bullet falls to the earth and crosses the line of sight again at 300 m. 25 meters. 150 meters. 300 meters. The distance the muzzle is raised may not be noticeable with the naked eye, but even at 25 meters, the muzzle is slightly elevated. Minute of angle, MOA, unit of measure. 1 minute of angle equals 1 inch per 100 yards. Sights and scopes move in minutes of angle. Wind is estimated in minutes of angle. 4, 2, 1, 3. 1 MOA. 100, 200, 300, 400, minute of angle, MOA, worksheet. 6 at 600 meters equals, MOA. 3 MOA at 200 meters equals, inch. 6 at 400 meters equals, MOA. 4 MOA at 300 meters equals, inch. 20 at 500 meters equals, MOA. 5 MOA at 300 meters equals, inch. 600 m equals 1 MOA. 3x, 200 equals 6 inches. 6/4 equals 1.5 MOA. 4x, 300 equals 12 inches. 20, 5 equals 4 MOA. 5 by 3 equals 15 inches. Value of clicks in MOA for iron sights. Weapon. Type. Elevation. Knob. Windage. Front. Sight post. M16A2. 1 half. 1 1/4. M16A4. M4. 3/4. 1 1/2. 300 meters elevation adjustment. Need to come down 12/12/300 m equals 4 MOA. 1 click on front sight equals 1 1/4 MOA. 4 MOA equals about 3 clicks on front sight. Impact. 40. Windage adjustment. Need to come left 21. 21/300 m equals 7 MOA. 1 click of windage equals half MOA. 7 MOA equals 14 clicks of windage. 19. Zeroing, what is the definition? The average answer is adjusting the sights so that the bullets impact where we are aiming. FM 3-22.9 states, the purpose of battle sight zeroing is to align the sights with the weapon's barrel given standard issue ammunition. Both answers are correct. Zeroing continued. The Army has developed methods for engaging targets based on the following two scenarios. Unknown distance equals battle sight 0, BSZ. Known distance equals bullet drop compensating, BDC, battle sight 0. A battle sight 0 allows you to aim center mass on a target and achieve a hit from 0 to 300 meters. A correctly zeroed rifle will impact within 10 inches of your point of aim. 10 inches, 32 meters, 150 meters, 300 meters. Line of sight. Trajectory, 400 meters equals 20 inches below point of aim. Battle sight 0. 350 meters equals 10 below point of aim. 400 meters equals 20 inches below point of aim. Trajectory. Line of sight. 300 meters. 350 meters. 400 meters. 10 inches. Bullet drop compensating. The elevation wheel on the rear sight is known as a bullet drop compensator. The numbers on the wheel represent distances in meters. How it works. Bottom out the rear sight and click up to 8/3 or 6/3. The BDC is now set for 300 meters. Clicking up to 4,5, 6, 7 or 8 adjusts the trajectory of the round to engage targets at the corresponding distance, i.e. 4 equals 400 meters, 5 equals 500 meters. 1 full revolution up from 300 correlates to the number on the left side of 3. For a 6/3 BDC the elevation would be set at 600 meters. This is why it is essential that the elevation wheel is bottomed out and then clicked up to 6/3 or 8/3 before zeroing. Elevation changes at 25 meters are made with the front sight post so that the bullet drop compensator can be used to engage targets beyond 300 meters. Sight is bottomed out therefore. The right number is used, 3, which indicates 300 meters. Gap is noticeable, the sight is up 1 revolution from 3, so the left number is used, 6, which now indicates 600 meters. Zeroing at 25 meters representation of M16 bullet path M16 A2/A3. 7-10. 25 meters. Zeroing at 25 meters. M16 A2/A3. Up 1 click. M16 A4. Up 2 clicks. M16 rear sights. M16 A2/A3. M16 A4. The difference can be seen in the thread pitch between a rear sight on a fixed carrying handle and that of a detachable. This is why you have to come up only 1 click on the M16 A2/A3 and 2 clicks on the M16 A4. Reference Army TM 9 1005 319 10 page 001100-7 number 4. This is the mechanical reason why 1 click on the A4 equals 2 clicks on the A2/A3. Difference in thread pitch. Representation of M4 bullet path. M4 zeroing. The M4 and M16 A4 share the same carrying handle, however the M4's shorter barrel produces less muzzle velocity. The line of sight and path of the bullet cross at 25 meters and at 300 meters. Pre-range departure/post weapon straw checks. Small rear sight aperture is up and windage index lines are centered. BDC is bottomed out and on. 300 meter setting. Front sight post is not bent or damaged and the base of the sight post is flush with the front sight base. Q. Do you need to set the rifle to mechanical 0 every time you go to the range? A. These presets should be set on a rifle if it is the soldier's first time firing that specific weapon. If it is the soldier's assigned weapon that has already been zeroed by that individual, this step should be waived. Which is center mass. Center mass including head center mass. Not including the head. Use a paper AE type and have a student come up and show where they perceive center mass to be. Then fold the target in half to demonstrate where true center mass is. True center mass would be aiming higher. At 300 meters the probability of getting the target is reduced because you are always higher than your point of aim with a 300 meters zero. Q. Which target is most commonly missed on a pop gual? A:150 m, because the trajectory is at its highest point. Q. How much is it above point of aim? 8:7 to 10 inches. Q. Where does that place the bullets on the target? A. In the neck or head, depending on the quality of the zero. It may in fact be more due to shooter error. This is why alternate points of aim are recommended for the highest probability of hits at to 300 m, in 23:9, fine ref. Modified zeroing target. Emphasize zeroing in the lower half of the 4 cm circle. This will ensure a higher probability of hits from 150 to 250 meters. If possible, 5-shot groups are recommended. Makes triangulation more accurate. 3-shot versus 5-shot. Introduction to the TAO1 in Asinakog 1240 6608. Characteristics of TAO1 in SN. 4x magnification. 32 mm objective lens. Waterproof to depth of 66 feet. Eye relief 1.5 inches. Field of view at 100 yards equals 36.8 feet. Adjustments equals 1/3 MOA per click, clicks/and at 100 meters, equals 3. Zeroing the TAO1 in SN2 methods, 100 meters zero, most accurate. Use center crosshair. Point of aim/point of impact. 25 meter combat zero. Use 300 meters reticle. Reticle/silhouette relationship at 100 meters. Introduction to the TA31F Cogscope in SN 1240 8428. Characteristics of TA31F. 4x magnification. 32 mm objective lens. Waterproof to depth of 66 feet. Eye relief 1.5 inches. Field of view at 100 yards equals 36.8 feet. Adjustment equals 1/3 MOA per click. 3 clicks equals 1 inch at 100 meters. Aiming points for 100 meters, 200 meters, 300 meters. For rapid engagement of targets less than 300 meters, use this hold. Zeroing the TA31F2 methods, 100 meters zero, most accurate. Use point of red chevron. Point of aim/point of impact. 25 meter combat zero. Use top of 300 meters post, underneath chevron. Zeroing the TA31F cones. 100 meter POA/POI 3 clicks equals 1 MOA. For both elevation and windage. Zeroing the TA31F cones. 12 clicks equals 1 for both elevation and windage. 25 meter POA/POI. Use top of 300 meters post. 12 clicks equals 1. For both elevation and windage. 9 clicks equals 1. For both elevation and windage. If red chevron is too bright, cover fiber optic with tape.